This is the Explortle Careers in STEM series. Today we'll dive into the world of geoscience. The ground beneath our feet holds secrets that have taken millions, even billions of years to form. From the towering mountains to the shifting tectonic plates, Earth is constantly changing. But who studies these processes? Who deciphers the story written in rock layers, water flows, and weather patterns? Today we'll explore the fascinating fields of geoscience, where science meets the power of nature. So, what is geoscience? Well, geoscience is the study of the Earth, including its structure, process, history, and natural resources. It covers everything from rocks and minerals to climate change and natural disasters. Geoscience helps us understand how the Earth works and how we can manage its resources and environment. Why is geoscience important? Geoscience helps predict and mitigate natural disasters, manage natural resources, protect the environment by studying climate change, pollution, and conservation, and supports engineering and construction by analyzing ground stability for buildings and infrastructures. Every crack in the Earth's surface, every ripple in a river, every gust of wind carries valuable information about how our planet works. Some people dedicate their life to uncovering these mysteries, whether they analyze minerals deep underground, design structures that withstand earthquakes, or track storms from space. These professionals play a crucial role in shaping our understanding of the world. Let's meet the experts behind the scene. First up, we have geological engineers. What are they and what do they do? A mining and geological engineer designs mines to safely and efficiently remove minerals from manufacturing and utility use. Most working in engineering firms, mining companies, construction sites, government agencies, and environmental organizations. Their work environment is split between office work, field investigations, and construction or mining sites. At times, their job may require them to work in extreme weather or hazardous conditions. Involvement with geoscience. A geological engineer works with soil, rock, and groundwater to design mines, tunnels, roads, and environmental protection objects. Next, we have hydraulists. What are they and what do they do? Hydraulists study water and how it moves across and through Earth's crust. Most work in government agencies, environmental consulting firms, water management organizations, and research institutions. Their work environment is a mix of office work, field search at lakes, rivers, and groundwater sites, and laboratory analysis. They are sometimes involved with working in extreme weather conditions. Involvement with geoscience. A hydrologist focuses on Earth water systems, studying how water moves through rock, soil, and ecosystems. Third, we have environmental sciences. Environmental sciences and specialists conduct research or investigations to protect the environment or human health. Most work in government agencies, environmental consulting firms, nonprofit organizations, and private corporations. Their work environment most often consists of working in an office or lab, but may involve fieldwork in various environments. And environmental sciences uses geoscience knowledge to manage natural resources, mitigate hazards, and develop sustainable plans. Lastly, we have atmospheric sciences. What are they and what do they do? Atmospheric sciences study, report, and forecast the weather and climate. Most work in government agencies, weather forecasting services, research institutions, and private industry. Their work environment is primarily office based with data analysis and modeling, but may involve fieldwork in extreme weather conditions. And atmospheric sciences uses geoscience data to track weather patterns, study air pollution, and predict climate trends. Not all engineering happens to sleek laboratories or high tech factories. Some engineers work where rock, soil, and water dictate the rules. They design tunnels through mountains, stabilize the ground beneath skyscrapers, and ensure that mines are both productive and safe. These, en- these engineers bridge the gap between nature and technology, transforming raw landscapes into thriving cities. But what does it take to become one? Let's dive into the world of geological engineering. The first career that we discussed that is STEM heavy is geological engineers. Geological engineers. As previously mentioned, a geological engineer designs mines to safely and efficiently remove minerals for manufacturing and utility use. But what education does a geological engineer need? Geological engineers typically require an associate's degree in applied science or science related technology. However, most employers may prefer However, most employers may prefer to hire applicants who have a bachelor's degree. Certifications and licenses aren't required for entry-level positions. However, a professional engineering PE license can be required later in one's career. Licensed engineers are called professional engineers. An FE exam can be taken after one earns a bachelor's degree. They're often called engineers in training, EITs, or engineer interns. In several states, engineers must earn continuing education credits to keep their licenses. When at work, most geological engineers work in offices, laboratories, and the field. Most work full-time. How should you get ready to become a geological engineer? In high school, you should take courses in math and science. High school students may want to adopt important qualities such as analytical decision making, logical thinking, math, problem solving, and writing skills. How much will you get paid? As of May 2023, the median annual wage for geological engineers was $100,640. It has been projected that from 2023 to 2033, the employment for geological engineers is projected to grow by 2%. Over the decade, about 400 openings for geological engineers are projected each year on average. Which career studies reports and forecasts in the weather, the climate? Before we head on to our next topic, here's a little hint to what we're going to talk about next. Which career studies reports on and forecasts the weather and climate? That is an atmospheric scientist. So, to become an atmospheric scientist, you'll need a bachelor's degree in meteorology or related physical science. They are also required to have taken physics, mathematics, and computer programming. Those who work in research may need a master's or PhD. Professional certification may benefit atmospheric scientists in some fields, though not required. They may choose to have the American Meteorological Society's Certified Consulting Meteorologist credential. Certification demonstrates level of knowledge that employers most often value. At times, employers may prefer to hire candidates who have the AMS designation of Certified Broadcast Meteorologist. Most atmospheric scientists work indoors. At times, they may work outside. Most are full time and may work extended hours during weather emergencies. How should you get ready to become an atmospheric scientist? In high school, you should take courses in physics, math, and computer programming as they are required. They may also want to adapt important qualities such as analytical communication, critical thinking, and math skills. How much will you be paid? The median annual wage for atmospheric scientists was $92,860 in May 2023. From 2023 to 2033, the employment for atmospheric sciences is projected to grow by 6%. Over the decade, about 900 openings for atmospheric sciences are projected each year on average. Now for our quiz time. You've learned a lot about geoscience, but how much do you really remember? It's time to put your knowledge to the test. Think carefully. These questions will challenge not just what you've memorized, but how well you understand the connection between science, nature, and engineering. Let's begin. First question, a company wants to construct a dam near a river, but they need to analyze the soil composition, groundwater flow, and structural stability of the area. Which two professionals would be the most necessary for this project? The correct answer is B, geological engineering and hydrologist. A geological engineer ensures the stability of the soil and rock formations, making sure the dam is built safely. A hydrologist studies the movement of water, including groundwater, river flow, which is crucial for managing the dam's water pressure and environmental impact. Next up, true or false? While geoscientists and geological engineers both study Earth materials, only geological engineers apply this knowledge directly to large-scale construction and mining projects. The answer is true. Geoscientists focus on studying Earth's composition, history, and natural processes, but not necessarily designing infrastructure. Geological engineers take this knowledge and apply it to engineering projects like tunnels, bridges, dams, and mines. Next up, we have a hydrologist is analyzing the impact of climate change on a region's freshwater supply. Which of the following would not be a primary focus of their research? The correct answer is C, the structural integrity of bridges near water bodies. A hydrologist would study groundwater depletion, precipitation changes, and evaporation rates, which is said in choices A, B, and D. However, assessing the structural integrity of bridges is a geological engineer's job, not a hydrologist. Think geoscience is just about rocks? Think again. This field takes scientists to the depths of caves, the summits of volcanoes, and even planets. Some study ancient water trapped beneath deserts, while others chase hurricanes to unlock their secrets. The more we explore, the more we realize that Earth and beyond is full of surprises. Here are some of the most fascinating discoveries from geoscience careers. If you're fond of traveling, then you would like the first fun fact about geosciences. It says that some geoscientists get paid to travel the world to study volcanoes, deserts, and deep sea environments. Another fascinating fun fact is that hydrologists played a key role in discovering underground oceans and other planets like Europa, which is Jupiter's moon. One last fun fact of the day is that some atmospheric scientists chase storms for research, literally driving into tornadoes and hurricanes to collect data. We've only scratched the surface of what geoscience has to offer, whether it's predicting natural disasters, protecting the environment, or exploring uncharted territories. Geoscience careers shape the world around us. If you're curious about Earth's past, present, and future, this might be the perfect field for you. Well, that's it for today's video. Thank you for joining us today. Don't forget to follow us on Instagram and stay updated on our STEM series. See you next time.